All right, in this example, we are going to find the specific heat of a metal through calorimetry. In this calorimetry problem, we heat up the piece of metal, place it in some water, and we measure the temperature change that occurs when that metal is placed in the water. We have to make an assumption here. The assumption is whatever heat is lost by the metal must be equal to the heat gained by water. Since heat is equal to Q, we can set these equal to MCAT. The MCAT of the metal is equal to the MCAT of the water. So we simply plug in values. We know we have 15 grams of the metal, so that's the mass of the metal. We don't know the specific heat of the metal, so we're going to leave that C or put X. And then my change in temperature. The metal started at 100 degrees Celsius. The final temperature of the metal-water mixture was 25.35, and we subtract to get our delta T. The mass of the water, again, since we set Q of the metal equal to Q of water, is 100 grams. We're assuming it's 1 gram per milliliter density. Specific heat of water, you should know, 4.18 joules per grams degree Celsius. And the water temperature didn't really change much. It started at 25 degrees and again ended at 25.35, so the temperature change was only 0.35 degrees Celsius. We're going to solve for C, so we're going to isolate that variable by dividing both sides by the mass and change in temperature of the metal. So we're going to take both sides and divide it by 15 grams times 74.65 degrees Celsius. Again, keep in mind when you plug in the right-hand side into your calculator, make sure that bottom part is in parentheses to keep your order of operations correct in your calculator. Notice on the left-hand side, everything cancels but my C, and I simply plug into my calculator 100 times 4.18 times 0.35 divided by 15 divided by 74.65, and I get 1.131 joules per grams degree Celsius.